Good morning, guys. I hope y'all are doing okay so far and having a good day. We're gonna be watching this video from my homegirl Elaine for this section of uh, nonlinear inequalities in one variable. Let me see. Where's this video? Oh, there it is. All right, so we'll play this.
During this segment, we will solve nonlinear inequalities in one variable. For example, we'll solve an inequality such as this. This is a quadratic inequality. If I multiply these two binomials, I would have a quadratic inequality. So be careful and make sure you realize what you're dealing with here. Not a linear, but a quadratic inequality. Here's how we'll solve a quadratic inequality such as this one. First, we'll look at the related equation. In this case, it is x minus 3 times x plus 4 equals 0. And let's solve the related equation. To solve this equation, notice I have 0 on one side. I have a factored polynomial on the other side, so I can use the zero factor property, set each factor equal to 0, and I would have solutions of 3 and -4. Now, these are solutions of the related equation, not the inequality. What we'll do, though, is the following. Take a number line, and on this number line, place the solutions to the related equation only. In other words, don't put 0 here because sometimes it tends to be a little confusing. We'll place only these solutions in the order that they would naturally appear on a number line. So 3, and to the left somewhere, -4. Now notice, these two numbers divide the number line into 1, 2, 3 regions. And here's what's so interesting about these 3 regions. If a single number in, say, this region makes this inequality true, every single number in that region makes the inequality true and is a solution. Same thing with this region and the same thing with this region. And that's what's so nice about the related equation. Solutions divide the number line into regions that entirely are solution regions or entirely are not solution regions. So, how do we find out what regions are solution regions? Well, we just need a test point. Pick any point less than -4 that would lie in that first region. Say -6. Let's check -6. Either -6 makes that a true statement or a false statement. Let's see. -6 minus 3, that's -9. -6 plus 4, that's -2. Is this true or false? Well, this is 18 less than or equal to 0. True or false? That is a false statement. So I would suggest you put some type of X there, telling yourself that that is not a solution region. Now, check any number in this region, any number between -4 and 3. I'll check 0. And I check it in the inequality because we're trying to solve this inequality. Well, if x is 0, what is 0 minus 3? That's -3. What is 0 plus 4? That's 4. Is that a true statement? That's -12 less than or equal to 0. That is a true statement, so I will place a check mark. And I know my check marks are left-handed check marks. You can place a right-handed check mark there. And now check that last region, any number greater than 3. If you want, you can check 100, you can check 1,000. It's up to you, but any number greater than 3. I'll check, say, 4. 4 minus 3 is 1. 4 plus 4 is 8. True or false? Well, 1 times 8 is 8, less than or equal to 0. That is a false statement, so I'll place an X there. And now what we do is the following. We just simply write down those regions that are solution regions, the ones we checked. The only region I checked was this one, so I will write down in interval notation then the solution region. I start at -4 all the way to 3. Now, because this is less than or equal to, or if it were greater than or equal to, I place a bracket about those endpoints showing that this makes it a true statement and this makes it a true statement. And that is my solution for this quadratic inequality. Let's look at some steps we can use. Solving a polynomial inequality. Step 1, write the inequality in standard form and then solve the
Okay, guys, so that's it for this section, and then I'll post another video for the next section. Let me see, I had to pause this video. Where's my recording? Ay. Did I close? Where's the video?